All right. Okay, so remember, this chapter is all about, okay, so you know how to find the derivative. How do we use it? Okay, so the questions you're going to see today aren't find the derivative. We're going to need to find the derivative, but those aren't the questions you're going to see in this chapter. Okay? You're going to see questions like equation of the tangent line. You're going to see questions like horizontal tangent line, vertical tangent line, relative maximum, relative minimum, increasing, decreasing, stuff like that. Those all involve derivatives, but they're not going to say specifically. Okay, so that's one of the big things. Okay, so the topic we're talking about today is called extrema on an interval. Extrema refer to four things. They refer to maximum and minimums. Maximum and minimum. So I give you a little picture here. So absolute maximum and minimum. So this interval goes from A to B, or A to E, sorry, A to E. Okay, that's what they call it. Interval means there's a beginning and there's an end. Okay, so extrema on, so things like relative, absolute, maximums. Okay, so absolute means absolute top and bottom. Maximum is the high point, the biggest Y value. Minimum is the bottom, the lowest Y value. Okay? So you can see A. A is the absolute minimum because there's no other Y value lower than A. That's the lowest. It's the lowest valley. D is the top mountain, the top hill out of everything. It's the highest Y value, so we call that the absolute. Okay? So those are absolutes. Absolutes are easy. Why is it absolute? Because it's the highest point or it's the lowest point overall. What are the relative maximum minimums? Relative means just for that general area. Just for that general area, it's a maximum or minimum. Like in this general vicinity, this is the top Y value. Overall, it's not the top. D is. But at B, it's a top, it's a peak. Okay? Same thing with C, it's a valley. Is it the lowest valley? No. Right? It's not Death Valley. Death Valley is the lowest part, right? But it is a valley. We're in a valley, right? We're in a valley, so that's, something like that, right? This guy is both absolute and relative because it is the overall high, but also for that area. Also for that area, okay? Another way to tell minimums, maximum and minimums is when there's a change. When there's a change from, to make a maximum, what do I have to do? I have to go from, am I increasing or decreasing right now? Increasing. And then at the maximum, I'm going to change to decreasing. So there's a change there. From increasing to decreasing creates some sort of maximum. Is it the absolute? Maybe, maybe not. Okay? Relative is the opposite. You go from decreasing to increasing. That's a switch. At that point, we switch, right? That's what we're going to do today. We're going to be on the lookout for relative maximum minimums and absolute maximum minimums. Okay? All right. So in terms of derivatives, right? Slopes. There's a change of slope, right? Here, I'm going uphill. So it's a positive slope, increasing, right? And then after the maximum, I change, right? After the relative max, I change. So what do you notice about the derivatives? There's a change. There's a change every time there's a relative or any kind of maximum minimum, there's going to be a change in direction, right? Instead of going increasing, we are now decreasing. Instead of decreasing, we're increasing and stuff like that. Okay? All right, so what to know? These are the big boys, right? So we just talked about it. A function may have both a maximum or minimum value over an interval. Sometimes they'll only have a maximum. Sometimes they'll only have a minimum. And sometimes they won't even have either. There will be neither, right? If I have a guy like this, if I have a guy that's just going like this, from A to E, it's not increasing or decreasing, right? So there's no maximum or minimums. So there, what would be the maximum for this guy here? what would be the maximum and minimum? There would be none, right? Because there's no peaks and there's no valleys, right? This guy there is. So sometimes there's not always both. Sometimes there's only one, sometimes there's the other. Okay, so how are we going to find the maximums and minimums? First thing we're going to do is find what's called a critical value, or critical number, sometimes they're called. Critical values are values of x. So when I say critical value, I'm talking about x, not y. Okay? Where the derivative is 0, or the derivative doesn't exist. Okay? So if I ask you for the critical value, you're going to figure out where is the derivative equal to 0, and if possible, where does the derivative not exist? Okay? So the critical numbers or critical points are always x values. They are always x values. While maximum and minimums of the function are always y values. Okay, so if we're talking about a maximum or minimum, we're going to use the y. If we're talking about critical values or critical points or critical numbers, those are x's. Okay, in other words, if the point 2, 70 is a relative minimum, we would say the minimum is 70 and it occurs at x equals 2. Okay? So it's just knowing the terms. Is that a critical value or is that a maximum or minimum? Okay, so it just depends on what you're referring to. All right, okay, so let's do, okay, so how are we going to do it? How are we going to find those numbers? Well, we're going to use what's called the first derivative test. The first derivative test, because we're going to use the first derivative. Okay, so what does the first derivative say? I just mentioned it earlier. If f prime is greater than 0. So when I say greater than 0, what does that mean? If something's greater than 0, what is it?
Positive.
Positive. So if the derivative is positive, then it's increasing. I'm going uphill. Okay? If I'm increasing, that means the derivative is positive. The opposite, if it's negative, then I'm decreasing. Then the original is decreasing. Okay? If the derivative is 0, it's constant. If it's 0, you're probably hitting a peak or a valley. That's where the derivative is 0. Right? All of these points here, all of these blue dots, the derivative is 0. Derivative is also 0 there too. All of those blue dots, that's where the derivative is 0. They're important because they represent maximum and minimums. Okay? So if the derivative is positive, that means the original f of x is increasing. If the derivative is negative, that means I am decreasing. Okay, actually notice these 2 points right here, the derivative is 0, but they're not maximum and minimums. They're what we call points of inflection. We'll talk about that later, but sometimes they don't always represent maximum and minimums, because these two guys here, they kept doing what they were doing before. It was increasing, then it paused, then it kept increasing. So that's not going to create a maximum or minimum. Okay? Okay. So let's do number 1. Let's do number 1. So again, does it say anywhere in the directions about finding a derivative? This is the word find the derivative, find dy dx, find y prime, find f prime. Are those anywhere in there? Not at 1, but we have to do it, right? So that's why this chapter is different than last chapter. If it doesn't say, last chapter, you can look at your test. It said find the derivative, find y prime, find f prime of x. Had all of those, right? This is where it's a little different. Okay, so for each function, find the critical numbers of f, where the function is increasing and decreasing. And then find all relative extrema. Find all of the maximums. So extrema means maximums and minimums. Max / mins. That's what extrema means. When they're talking about extrema, they're talking about maximum and minimums. Okay? Well, the first thing I have to do is figure out where is it increasing and where is it decreasing? Because when it changes from increasing to decreasing or decreasing to increasing, that's going to be a maximum or minimum. Okay? So the first thing is, where are those points at? What do we call those? Critical numbers. So find the critical numbers. Critical values, sometimes they're called. Okay, so the first step to find critical values is find the derivative. The derivative is going to be 3x squared minus 12x. Set it equal to 0. Set the derivative equal to 0. And solve. Well, it's a binomial. They both can be divided by 3x, so 3x is the GCF. I'm going to set 3x equal to 0 and x minus 4 equal to 0. Then I'm going to divide by 3, so I get 0. Add 4, I get 4. So there's two critical values at 0 and at 4. So at both of those, so at both of these guys here, the derivative equals 0. The derivative equals 0. Horizontal tangent lines, aka horizontal tangent lines. Okay? So what we just found was the peaks, those blue dots. We just found blue dots. We found one at 0, one at 4. I have no idea whether it's a maximum or minimum, though. I need to figure that out. Or if it's one of these guys, which is neither, right? So my next step is to figure out, okay, which of these dots is a maximum, which is a minimum, which is neither. That's where we're going to use the first derivative test. Okay, so we're going to set up the first derivative test. First derivative test involves a number line. What do we put on the number line? You put the critical values. Any critical value you saw, you put on the number line. 0 and 4, right? So I'm going to put 0 here, and I'm going to put 4 here, because that's where they appear on the number line. I know at 0 and 4, the derivative is 0. There is no derivative. But what I knew using this for is to figure out what's happening in between. Like in between, is the derivative positive or negative? After 4, is the derivative positive or negative? Less than 0, is the derivative positive or negative? That's what I'm trying to do. So the first derivative test says plug in numbers to the derivative. Okay? So if I want to figure out before 0, left of 0, less than 0, if I want to figure out a number, I'm going to pick one. -1, -2, -10, -100, -1,000,000, whichever number you want that's less than 0. I suggest using nice numbers. I wouldn't use -996,000 for, I wouldn't use that number. Use a nice number, -1. It's the first derivative test. So that means I'm going to plug it back into the first derivative. This is the only time you plug things into the first derivative, not the original. Okay, we're not plugging it into the original, we're plugging it into the first derivative. Okay, so the first derivative is here. Okay, so I'm going to plug in -1 into the first derivative. I don't care which number I get. Value does not mean anything to me. All that means to me is if it's a positive or negative number. That's all I care about. Sign is all I care about. Okay? So 3 times 1, negative 1 squared is negative 1. This would be plus 12 because you multiply it. We get positive 15. Positive 15. Since 15 is positive, that means every number I was to plug in before 0. You could plug in another number, negative 2, negative 3, negative 4, negative 10. You can plug in any negative number to the first derivative, and it will always be positive. So we're going to put positives over there. Anything before 0 is positive. Now here's a question. What is that? What does the positive mean? It's increasing. It means the original f is increasing before 0. Okay, so now let's pick a number between 0 and 4. 3, 1, 2, 2.5, 3.68242, any number you want. Pick a nice number. 1 or 2 or 3, any of those is fine. Because remember, we can't use calculators for this. So make it easy on yourself. Squared. Because this is the first derivative, right? So I'm plugging it into the first derivative again. So I get 3 minus 12 is negative 9. So that means any number I would have plugged in, if you plugged in 2, you'd still get a negative. If you plugged in 3, you would still get a negative. That means the original function was then decreasing from 0 to 4. Last spot is greater than 4. 5, 6, 7, 8, 9, 10, 20 million, whatever you want, plug it in. So I'm going to plug in 5. I don't want to plug in big numbers since I can't use a calculator. So 5 and 5. So 5 squared is 25, times 3 is 75. Minus 60 is positive 15. I could care less about the number 15. I just want to know if it's positive or negative. This guy's positive. That means after 4, it goes back up. Now let's answer the question. The question said, give me all of the relative maximum minimums. Okay, so we're going to say relative max at, here's the question now. Where is the maximum? When x equals what? 0, yeah, 0. Why 0? You're right. Why 0?
Because it's increasing and then decreasing.
Increasing before, then decrease. It switches, right? It switches from increasing to decreasing at 0. So that's going to be a maximum. Good. X equals 0. Sometimes they want you to justify. Justify means why did you pick 0? Exactly like Macy said. Macy just said the right answer. I want to justify it, right? So it switches. So we're going to say f prime of x switches from a positive number to a negative number. F prime switches from positive to negative. It was positive before 0, negative after 0. So f prime switches from positive to negative. These are these are free response questions waiting to happen. Free response questions are very popular for asking about relative maximum minimums. And when they do, they always want justification. Justification means, how do you know x equals 0 is right? That's how I know, because it was increasing before, decreasing afterwards. It's got to make a max. Okay? Now relative minimum. Relative minimum at x equals 4. Good.
How do we know it's relative and not?
Great question. We don't know, but we're just going to put relative because could it also be absolute? Yes, but we'll do that later. Yeah, we know it has to be at least relative. Yeah, because f prime switches from negative to positive. Done. Okay. Again, these could also be absolute, but we don't know. So all absolutes are also relative, but all relatives are not absolute. Okay? So that's why they usually ask you to find relative. We'll do absolute a little later, but yeah, they'll always ask you, most of the time they'll ask you for absolute. Okay? All right, let's try another one. Let's go example number 2. This one's a little more specific. They just want the x-coordinates of all relative minima. Minimum. Or sorry, minima means both. Sorry, minima. So it doesn't say, or sorry, wait. It's minimum, right? It's plural for minimum, yeah. So instead of saying minimums, minima. So do they care about maximums? No. Yeah, minima is plural for minimums. Okay. Mm-hmm.
What about for maximum? Is it maximum?
It would say maxima. Or it'll say relative extrema. If it said relative extrema, both. If it says relative minima, that's only minimums. If it says relative maxima, that would be maximums. Yeah. Okay. Again, we need to know where it's increasing and decreasing. So we're going to use the first derivative test. The first derivative test says we need critical values. Critical values. First derivative is going to be negative 3x squared plus 6x plus 45. Next step, set that equal to 0. It's a trinomial.
ABC.
Before that, you could, yeah, that's what we're going to do next. Before that, though, they have GCF. You can divide them all by negative 3. So it would be positive x squared, negative 2x, negative 15. Now you would do ABC. A equals 1, B equals negative 2, C equals negative 15. Negative 15, negative 2. So the two numbers that multiply to be negative 15 and add to be negative 2. Negative 5 and positive 3. So since this is not a Math 2 or Math 3 class, I'm going to show you guys a little trick that makes this go faster. So usually, like my students, I would teach them the box. Like Math 3 right now, we use a factoring box, but I'm going to teach you another method that will go faster. You can use this or you can use your other methods. It's up to you. It's called, what is it called? Slip and slide, sometimes it's called, or sometimes it's called bottoms up. So what you do is you get your two numbers, right? Negative 5 and positive 3, right? Minus 5 plus 3, right? And then you divide by A. What was our A term?
1.
So you would divide by 1, you would divide by 1. If you can divide, divide. If you can't, this guy comes up. The bottom comes up. If you can't divide. Well, I can divide, right? 5 divided by 1 is negative 5. 3 divided by 1 is positive 3. So you got you there. And then we have a GCF in front too. I can't forget about that. Yeah, you just divide by A. Instead of the box, you could just divide both of those by A. Okay, so we're going to get two answers. What are the two answers we're going to get? 5 and negative 3, yeah. The zeros. How do I know they're zeros? Because if I plug in 5, I get 0. If I plug in negative 3, I get 0. Those are our critical values. That's where the derivative equals 0. That's where a change happens. What type of change? Positive to negative, negative to positive, no change. We're going to find out here in a second. First derivative test now. First derivative test, now that I got my critical values, do the first derivative test. Put my numbers on there. I got negative 3, positive 5. Pick numbers to the left of negative 3, in between negative 3 and 5, bigger than positive 5. So I got to pick 3 numbers. It doesn't matter what numbers you pick. We're all going to get the same signs. So I'll pick negative 4. I'm going to plug this back into the derivative because it's the first derivative test. So negative 3 parentheses squared plus 6 parentheses plus 45. And then I'm going to plug in negative 4 first. Negative 4 squared is 16. Negative 24 plus 45. This is negative 48 minus 24 plus 45. Again, I could care less what actual number it is. I just want to know, is it going to be a negative number or is it going to be a positive number? It's going to be negative, yeah. It's going to be negative. That's all I care about. Because now I know every number to the left of negative 3 is going to be a negative number. So I'm going to put some negative signs here. That means before negative 3, the original f of x is decreasing. Pick a number in between. If you can pick 0, pick 0 because things cancel out when you pick 0. So in this case, I'm going to pick 0 for the in between negative 3 and 5. I get 45, positive 45. Last one, bigger than 5. 6, 10, whatever number you want. I'm going to plug in 6. So negative 3, 6 squared plus 6 times 6 plus 45. So 6 squared is 36 times negative 3.
Negative 108.
Thank you. Negative 108 plus 36 plus 45. Again, don't care if it's what number it is. I just want to know if it's going to be a positive or negative number. It's going to be negative. If I were to add and subtract, you guys will get negatives.
Negative 25.
Decreasing again. So it was increasing between negative 3 and 5, decreasing when x was less than negative 3, and then increasing after or to the right of positive 5. Okay, so now, again, let's go back. Let's actually answer the question now. Relative minima, or minimum, because there's only one, right?
Negative 3.
At x equals negative 3 because, how did we know it was negative 3?
Because it goes down and it goes back up.
F prime of x switches from negative to positive. Before -3, I was decreasing. After -3, I was increasing. So that creates a relative minimum or minima. Okay. Even though it didn't ask us for justification, I always put in the notes because they will eventually start asking you for justification. And if you're used to it, it's no big deal. But if you're not used to it, that's where it could become a little bit. You're like, well, why? Okay. All right. What the heck? Why is there a big blank? Oh, okay. I know why. Okay, so number 3. Same thing. Find the critical values, increasing, decreasing, find all relative extrema. Relative extrema means any of them. Relative maximums, relative minimums. So the first thing I got to do, find the critical values. To do that, I need a derivative. To do that, I need to use the quotient rule. Low squared on the bottom. So low times the derivative of the high, which is -1, minus the high times the derivative of the low, which is 2x. Okay, so I'm going to simplify this, distribute. I get -x squared minus 4. Then I'm going to distribute here and distribute there.
Gives you positive 2x squared.
It's going to give me positive 2x squared. Then I can combine some like terms on top. It'll be x squared minus 4 over x squared plus 4 squared. That's the derivative. So I can combine this guy and this guy. Okay. Set it equal to 0. Yes.
Didn't you also simplify that?
Yeah, it's the top is difference of squares, right?
Yeah.
So it'd be x plus 4, x plus 2, x minus 2. We're going to do that in a second, yeah. But not, I haven't done it yet. We will do it. We will do it. So here we go. I have this guy now. So past directions say set it equal to 0. Well, which part of this is going to make it 0? The top or the bottom? When the top is 0, that means it's 0, right? So I'm not going to set the whole thing equal to 0. I'm going to set the top equal to 0. What happens when I set the bottom equal to 0? Yeah, right? That's also a critical value. So I got to set the bottom equal to 0 as well. So yeah, like Seth was saying, the left is difference of squares. Or you can add 4 and take the square root. Either one works. It's difference of squares, so you're going to get x plus 2, x minus 2. So you're going to get x equals -2 and positive 2. What about the other side? No. What do I do with this side here? This has nothing to do with calculus. This is more of a math 2, math 3 question. No, it's not difference. It's close because it's plus. It's not minus. So it's not difference of squares. You could, but there's no reason to. There's no reason to go any further. Why? It's never going to equal 0. Yeah, why not? Why won't this guy equal 0?
Because of the x squared.
Because if I square it, doesn't it become positive? And then if I add it, doesn't it become a positive? And if I square it again, doesn't it become positive? So is there any number I can plug in there where it won't be 0?
Besides imaginary numbers.
Yeah, because even if I plug in that, right? Even if I plug in a negative 4 squared is 16. 16 plus 4 is 20. 20 squared is 400. There's no number I can plug in here that would ever give me 0. Positive, negative, it would have to be an imaginary number. And in this class, we don't deal with imaginary numbers. We only deal with the real numbers. How do I solve this? I was waiting for someone to say, oh, you can solve it. Square root both sides. Square root of 0 is 0. Subtract 4 from both sides. You'd get imaginary there. Because you can't have, there's no two numbers when you multiply it makes negative 4. So this side's not going to give us any answers. So the only answers we got are negative 2 and positive 2. Okay. Now we have to figure out where is it increasing, where is it decreasing. So we're going to use the first derivative. Oops, not F, G, or H. Pick a number to the left of negative 2, negative 3, negative 4, negative 5, whatever number you want. Doesn't matter. I'm going to plug in negative 3. First derivative test, so we plug it into the first derivative. So that's x squared minus 4 over x squared plus 4 squared. So I plug in negative 3 and negative 3. So didn't we just say that we'll always get a negative on the bottom? We'll always get a negative. It doesn't matter what number you plug into the bottom. Like if I plug in negative 3 squared is 9, plus 4 is 13. 13 squared is 169. It's always going to be a positive number. Am I going to get a positive or negative number on top? Positive. What's a positive divided by a positive? Positive. Okay. Now plug in a number in between.
Negative on top of a positive.
So I'm going to choose 0. Let's see. So we get 0 squared minus 4 over 0 squared plus 4 squared. So yeah, for this one, I'm going to get a positive on bottom again, and then a negative on top, right? And what did division rules say? If you got a negative divided by a positive, what is the overall answer? Negative. And then pick one bigger. I'm going to pick positive 3 again. So I'm going to get a positive 5 on top, and I'll always get a positive on bottom for this problem. So positive divided by a positive makes a positive. So increasing, decreasing. So they want to know about everything, minimums and maximums. So we're going to say relative maximum at x equals, so which one is going to be a maximum, negative 2 or positive 2? Negative 2, because f prime of x switches from positive to negative. Or it switches from increasing to decreasing, either one. And then I'm going to say relative minima at x equals positive 2 because f prime switches from negative to positive. At positive 2, it goes from blue to red. At negative 2, it goes from red to blue. Done. Okay. Okay. So the last thing we're going to do today. We know how to find relative maximum minimums, but what about, could one of these guys be an absolute and we don't know it? We're going to find out. We are going to find out with example number 4. So, extreme value theorem. You don't need to know the name of it, you just need to know what it does. States that if a function f is continuous on the closed interval from a to b, then f must have a maximum of absolute maximum and an absolute minimum at least once. So if it's continuous on the closed function, it's going to have one of each. It's going to have one of each. Okay? Sometimes we call the absolutes global. Sometimes you'll see that word global. It's an old school word that you don't see a lot anymore. You see absolute, but sometimes they'll throw in a global. Global means the same thing as absolute. Okay? So where do we check? Well, we're going to do the same thing we've been doing. We're going to do the same thing. I need to know all relative because I got to check those. And then there's 2 other points I need to check. The beginning and the end of the interval. Okay, so I'm going to check. First thing I'm going to do, this guy right here, is what you've been doing this entire time. That guy is not going to change. We're still going to start there. The only other thing we're going to do, though, is we need to check to see if they're actually absolute. Okay? So the beginning of this problem is going to be exactly like the beginning of the other problems. I need my critical values, critical points, critical values. So let's do that. Critical values. Okay. What do we start with when we're looking for critical values? The derivative. So that's going to be 3x squared. What? Okay. 3x squared plus 18x plus 27. Then what do we do? Set it equal to 0. It's a trinomial again. It's got a GCF of 3, so I'm going to divide everything by 3. Plus 6x plus 9. A is 1, B is 6, C is 9. 9, 6, be 3 and 3. So it's going to be x plus 3 and x plus 3. Divide by a. Well, a is 1 again. So you can divide by it. It's just going to be x plus 3 because it goes in. And then I have my GCF in front. What am I going to get for x? Negative 3, yeah. Negative 3 twice. You just need to write it once. So we get 2 answers, but they're both negative 3. Okay. First, so Here's the thing. I don't necessarily, so I'm not going to do the first derivative test here. The reason is I don't care. It's a relative, I know that. My goal is to find the absolute, right? So I'm going to skip the number line. I'm going to go right to checking. So how do we check? Checking is really easy. You just got to remember to do it. How do we check it? We make a little table. The left side is the x values, the right side are the y values, or f of x. What goes on the left side? Well, the first thing that goes on the left side is your critical values. I only got one. The next are what we talked about up here. The beginning of the interval and the end of the interval. So the beginning of the interval was -5, and the end of it was -1, right? Those are the other two that we check. I'm looking for the absolute. So absolute has the highest y value. So whichever one of these guys gives me the highest y value, that's my absolute. Okay? Since I'm not using, yeah.
Are we finding it for the original function? Or
The original. It's going to be the original. Because I'm not doing my, the only time we do the first derivative test is when I want to know if it's increasing or decreasing. For absolute, you can bypass that. Yeah, so we're going to go back to the original. We're going to go, this is where it's different. Because we don't go to the first derivative test, we go back to the original. Okay, so now I'm going to plug in -3 back into the original. I'm going to plug in -5, -1 to see which one gives me the biggest y value. Okay, so cubed plus 9x squared plus 27x plus 3. Okay. So first thing I got to do is plug in -3. And then -5. And then -1. Okay. So let's see, let me change the color. -3 cubed is -27. -3 squared is 9. Times 9 is 81. 27 times 3 is 81. Plus 3. So the 81s are going to cancel out. And really you just have -27 plus 3, which is -24. Okay. -5. -5 cubed is -125. -5 squared is 25 times 9. It's 225. 27 times 5 is, what was it?
135?
135
-135.
plus 3. Okay. So let's see. -125 plus 125 is 100. Minus 135 is -35. Plus 3 is -32. Last one, -1. So that's -1 plus 9 minus 27 plus 3. So that's 8 minus 24. So that's -24.
What happened to the?
No, not -24. Yeah, not -24. There you go. Thank you. Yeah, I knew it looked weird. -16, sorry. Mental math. Which one's the absolute?
-1.
-1. -1's the winner because it has the biggest y value.
Would it be possible just to look at the pattern of the 2 instead of doing all 3?
Yeah, for sure. For sure, using number theory, you knowing what you know about numbers, looking for patterns, absolutely, yeah. So let me finish this one. Let's see. Relative, so we would say absolute maximum.
At x equals -1 because it has the highest value.
There you go. Exactly. Maximum at x equals -1 because y value is the highest because y equals -16. Something like that.
Glory,
Yes.
when can I retake the test?
Once you've done your error analysis, do that first, and then we'll